When we talk about mobility, as long as the mobility is limited, for instance, it is within the same subnet, the IP address does not change, and it is very easy to move from the jurisdiction or the range of one access point to the other. And the ongoing connections can be kept in continuity. In this module, we shall talk about mobility as a problem in itself when the mobility is either too frequent or the mobility is larger in magnitude. Then we'd look at a standard which has evolved called the mobile IP standard. We'd look at the elements and we'd look at some of the procedures. Finally, we'll conclude with an example of indirect routing scenario. The reference for this particular module is mainly by Quiroz and Ross, Computer Networking, Top-Down Approach. However, very good discussion does exist in Tannenbaum and William Stallings as well. Let's look at first the degrees of mobility. Here we see a spectrum. On the left-hand side, we see that there's no mobility at all. No mobility actually means you are working on workstations. And then we have high mobility. The farthest could be thought of as 4G LTE network, where you are driving in a car at high speed and you are using your smartphone to access the internet. Here you're working on simply PC. Within these two extremities, we can have some varied levels of mobility. For instance, when the user moves only within same wireless access network, either on foot or with limited mobility on a transport, that's the kind of mobility that we expect either within a building or on a campus. Then the user moves between access networks, shutting down while moving between these networks. So there could be coverage void region in which you are leaving a network and you're accessing another network, and during this, the communication has to come to a standstill. Then the user moves between the access networks while maintaining ongoing connections. It means that the connections have to be kept on while the user is moving. So we see that from PC to 4G LTE compliant smartphones, the degrees of mobility are many, and we need to think about a method or a mechanism that allows us to support such mobility behaviors. We have mobile IP standard, which is based on RFC 3344. Mobile IP standard defines the entities, defines the procedures, and defines some additional mechanisms on part of the host and access point and router implementations, which allows mobile IP to be implemented in letter and spirit. For instance, there is a list of elements. It comprises home agents, foreign agents, the care of address. Then there are certain procedures. For instance, we have registration of a mobile node with its parent network and with its visited network. And then the process of tunneling or encapsulation, that is, the packet is carried within a packet. It means such packet has two IP headers, one for the home network and the other one for the foreign network. Let's see how does that work. Here in this diagram, what you see is that we have home network. This home network is actually the permanent home to the wireless node here. The permanent home in this case is 128.119.40, and the IP address given to this host or this computer, which is mobile in nature, such as a laptop, is 128.119.40.186. The router, which is responsible for this network, is called the home agent. Then we have the laptop, which now behaves like a mobile node. It enters into a foreign network. This foreign network is called the visited network, which has, say, the IP address range as 79.129.13, and of course, it has a certain notation, subnet mask. Then it is entering, so it is given an IP address through which it is going to operate in this network. That's called the care of address. The router, which is responsible for the guest mobile node within its network, is called the foreign agent. And now, as you may observe, the mobile node is carrying its own permanent address as well. So it means it is a foreigner which is given a temporary address here, and the foreign agent knows about it. Now, here for this visitor, foreign agent is acting as the host. If there were another computer or a mobile node which was entering from this network to this network, this home net agent would serve as the foreign agent for that visiting node. Then, for these two wireless networks, we have a connectivity to the World Wide Web, to the internet. And imagine that we have a computer, we can call it a correspondent node, that wishes to communicate with this mobile node. Now the question is it going to communicate directly? If directly, then how? Or if indirectly, then how will it make sure that the correspondent node goes to the home agent? From the home agent, it goes to the foreign agent, and from the foreign agent, it is delivered to the mobile node. There are certain procedures which are defined for mobile IP to work successfully. The first one is, of course, agent discovery. A mobile node or a mobile host would know of if it has moved or if it is still in its parent network by discovering the agent. Using the agent communication and agent IP address, it will get to know if it has already moved. If it has already moved, then what will happen if it has to register? So there's a registration process through which a mobile node keeps in contact with its home network while it is in the foreign network. Then we'd look at an interesting use case of indirect routing, which is the adopted standard in mobile IP. Here in indirect routing, what we see is that the correspondent node is now communicating to the mobile node through the home agent. The home agent has since registered the mobile node to be in the jurisdiction of the foreign agent. So the transmission from correspondent node is forwarded to the home agent. From there, it is sent to the foreign agent, and then foreign agent delivers it. Now, the mobile node knows the IP address of the correspondent node, so it is going to reply the correspondent node as such. So we see that this involves a kind of triangulation. Of course, triangulation has its own constraints, but for now we'll keep our discussion restricted to the fact that mobile IP supports indirect routing.